Our discussion today is going to be about adding and subtracting rational functions, expressions, and here the rules are different because we're dealing with adding and subtracting. So the rules are simply, number one, you must get a common denominator. So get a common denominator, and then when you get a common denominator, what you're going to do is either add or subtract, depending on what we're dealing with, the numerators, the tops. So copy those rules down. Let's look at how do we get a common denominator. So what number is common between 3 and 6? So that number would be 6. So we don't have to do anything with this second function. So that would just be a minus 5. What is, now I have to change the thirds into 6. So if I multiply the 3 by 2, I have to multiply the top by 2. So 2 times 2 is 4. We have a common denominator. All we do is add or subtract the tops. Since we're subtracting, we'll subtract the tops. And 4 minus 5 is a negative 1. 6. So that's how we do it with numbers. When we have variables, we'll do the same exact thing. So what is the same exact thing? We'll look to see what is a common denominator. So what's common in the x and the 6? Nothing. So you just multiply those together. So we get a 6x is our common denominator. And then how do I change this x to look like 6x? I'm going to multiply the bottom by 6. Whatever I do to the bottom, I must do to the top. So 6 times x is 6x. 6 times 2 is a 12. How do I change this 6 so that it looks like 6x? I'm going to multiply it by an x, which means I have to multiply the top by x. So 5 times x times x. We usually write that a 5x times x. We usually write a 5x squared. This will be the final answer because we learned last section that we cannot cancel any x squareds on the top and bottom because we have a plus or a minus sign. So again, our steps are simple, but sometimes it gets a little complicated. The steps are simple. We multiply the bottoms together so that they're common. And then once the bottoms are the same, then all we have to do is add or subtract the tops. So in example 3, let's check. The bottoms are common. So then if the bottoms are common, we don't have to do anything. The denominator stays the same, and we subtract the numerators. That's our final answer. Again, we can't cancel because we have plus minus signs. And in example 4 and 5, I'm just going to ask you what the least common denominators between these are. So if this is in the denominator and so is this, how do I determine what the least common multiple is? So you remember how to factor a 4x. We get a 2x and a 2x. How do we get a 16? We get a positive 4 and a minus 4. For the 6x squared, remember we have to take the 6 times the 24, which is 6 times 4 is 144. So what are the factors of 144 that add up to negative 12? That would be a negative 12 and negative 12. So we need 6x. So we'll go 3x and a 2x to give us a 6x squared. We need a minus 12 and we need a minus 12. Let's check to see if this works out. 3x times 2x is a 6x squared. We've got a negative 12 and a negative 12 to give us negative 24. And a negative 6 times a negative 4 is equal to a positive 24. Okay, so a common denominator for this particular problem, if these were in your denominator, what common means is that you don't have to repeat. So you see that they have a 2x minus 4, and this has a 2x minus 4. So a least common multiple would be a 2x minus 4, and then you'd need the 3x because it's not common, and you'd also need this 2x plus 4 because that's not common. Okay? But you do not have to repeat the 2x minus 4. Let's try example 5 in kind of the same vein. How do we factor out neither 5x squared or 45 is a perfect square, so let's factor out that 5 first. That would give us an x squared minus 9. Oh, then we can factor that. X minus 9 factors to an x minus 3, x plus 3. So that's how this first term would factor. Let's see how, again, let's check. We've got a 4 goes into all 3 of these, so let's factor that 4 out. That would give us an x squared and a 6x and a 9. Are there any factors of 9 that add up to 6? So let's write that factor out. So we'd get a 4, we'd get an x plus 3, and an x plus 3. Okay. So to look for least common multiples, what we're going to do is, again, we're going to look at this and these. Okay. And what is the least common multiple between a 5 and a 4? Well, the least common multiple between a 5 and a 4 is a 20. So the first thing you have to do is get the 20. Then we have an x minus 3 and an x plus 3 here, and we have 2x plus 3's here. So we'll need the x plus 3 is common, so you only need those one time. Now this fraction has another x plus 3, so we'll need that. And this has an x minus 3, so we'll need that. And this big, if these were in the denominator, this would be your least common multiple. So problem number 6, let's see if we can find this least common multiple and then see if we can add. So if I look at the 3x, they both have a 3x common, so I'll factor out a 3x times x plus 3. So how can I see what's common between a 3x squared and a 9x squared and a 3x? Well, what's common is a 3x. They both have a 3x term in it. And if I write this as a 3x times a 3x, so we can see that these are both in both denominators. So we don't have to repeat those. But we have to repeat what's left over. So we have to repeat another 3x. And this x plus 3 on the second equation is not there. So you don't have to duplicate the ones that are common in both of them, but what's left you have to multiply through. Okay. So how am I going to make this 9x squared look like this now? So look, it has an x plus 3, or an x, 3x and a 3x, but it doesn't have the x plus 3. So in order for this fraction to look like this, it needs an x plus 3 on the bottom, which means I have to multiply by an x plus 3 on the top. So my new numerator, let's use distribution. I've got a 21x. No, I don't. I have a 7x when I distribute. 7 times x is a 7x, and 7 times 3 is a 21. Okay. Now let's look how I'm going to change this fraction. I need this fraction to look exactly like this. So it has a 3x, it has an x plus 3, but what is it missing? It's missing another 3x. So that means I have to multiply top and bottom by what it's missing. So this new numerator will become a 3x. x squared. So to simplify, we'll put our common denominator on the bottom. We might see this written as 9x squared times x plus 3. And then the top, let's rearrange these so they're in standard form. But there's no way we can simplify this because, again, we have adding and subtracting. So this would be our final answer. I want you to practice some adding and subtracting. We'll start with problem number 7 in tomorrow's lesson and go from there. Good luck.